in my previous video, you saw that we're going to have this dynamic drop-down menu for this HDA, and basically it's going to automatically populate with all the texture types that it has found in directories that we are searching for. So we want to recreate this ability on our HDA. So let's go ahead. This is going to require us to use some Python code. So let's go to type properties, go to the scripts and create your Python module. Then apply it, and to make it easier to follow, I want to go ahead and edit this Python module for this HDA in my external editor. So once you have Python module, you can right click on it, and as long as you have set up your external source code editor, you can go ahead and open this up in your external editor. So I'm going to use a PyCharm. Go ahead and start by importing a couple of modules that we are going to use. So these are all the modules that Python comes with, so we don't have to import any custom modules. So let's go ahead and start with this. So we want OS module. OS module is going to be used to navigate file system of the operating system. So obviously we're working with the directories from the operating system, so we probably want to import this one. So we're going to use also RE module. So RE is going to be our regular expression module, will be used to find texture files in directories based on determined naming scheme. So I'm going to go through it a little bit later, but it's very useful to have. And then from the collections, we're going to import the default dictionary. So the default dictionary will be used to storing texture sets and parsing of data. So default dictionary is a subclass of the directory object inside Python, and the added benefit of the default dictionary that any key that we are providing, it has already a default value for it. So it's never going to throw us any key error that this key doesn't exist. The default value is always there, and this is very beneficial for us to not to check for the key validity or anything like that. So this is a very common import that I'm using default dictionaries. Okay, so now let's go ahead and let's define a couple of constant values that we're going to use across this Python module. So I'm going to start by defining, let me make it a little bigger. Let's start by, right. Let's start by defining a couple of constant values that we're going to have across this Python module. So first I'm going to give some variables for the names of the nodes that I want to cook from my Python code. So we have not yet created these nodes, but I know that I'm going to create these nodes and I'm going to call them remove output, remove fails, and copy unmatched. So this is basically the name of the nodes that I want to cook from my Python code. And then we also want to get our parameter references also defined inside this code. So these are all the parameters from the HDA parameters. So let's go through them. So I basically prefix them with the parameter menu or the node prefix, so that I know what this variable is referenced to. So the parameter discovery mode is basically this parameter mode. Parameter root directory, which is this directory parameter. Parm file extension, this one. Output to this menu. Parm output directory, basically custom output directory is going to be this parameter. And show only common types is going to be this checkbox. So this is all the parameters. We're going to have to know these values. So it's a good idea to basically, since these values are never going to change, and we are probably going to reference some of these multiple times, it's a good idea to basically create references to them, to their names, so we don't have to change it later on if we are changing it. If you're changing the parameter name, to change it, go ahead and hunt our Python code to change all of the occurrences of these parameters names. Now let's go ahead and define also the regular expression that I'm going to use to find my texture set. So the regular expression is something like this. So it's basically our regular expression module, and there's a ability to compile a regular expression. So this is a function compile, which is basically just going to hold the string value of the regular expression. And this is a regular expression that we're going to use to find these textures on the in directories. So let me go ahead and go through, if you're not familiar with regular expressions, what they are. So they are basically more advanced group matching, group wildcards. So if you have worked with Houdini, you know that you can use something like asterisk to say, let's say in delete group, delete everything that starts with, basically this grouping means that everything which starts with a pig, and asterisk, and that means that match every group that starts with a pig, and then anything that after that, delete everything. You see, by default we have pig, face, eyes, neck, and throat, and if we give it the asterisk wildcard, it's going to delete every one of these groups. And then if you want to exclude some of them, we can use a caret. So you see, again, you delete everything except for the caret, and if it ends with a neck, do not delete. You can see we have not deleted the neck group. And to expand the topic of the regular expressions, let's actually go ahead and recreate this wildcard group inside regular expressions. So what you can do is go to the regex101.com, and you can basically give any string, and you can write your regular expression to try to match these strings. So what I did is basically went ahead and copied all the groups, all the group names, and copied all the groups, and let's try to match it just like I did inside Houdini. So I want to go ahead and start writing pig, and you can see these blue markings mean that we are matching these. And you can see match information also here, and also explanation of the match. Pig matches characters pig literally and case sensitively. So what we do is now, let's say I want to face, you can see it's only going to match that. So we want to use tokens. So instead of wildcards, for regular expressions we have tokens, and one token is match any word character. You can see it's \w. If I go ahead and say \w, you can see after the pig any word character, which is basically upper and lower case English letters, 0 to 9, and underscore is considered the word character. Basically you can see it matches every word character. If we have pig, but then the next character is like a question mark. Question mark is not a word character, it's not going to be matched. So what to do is go ahead and match everything after the word character. So I want to make this, then we have a quantifiers. Since we never know how many letters we have after the pig, what we'll do is match it many times. Basically, this token, we want to match this token many times, basically unlimited times, to match everything after that. And there's a couple of common text tokens. You can see there's a bunch of 0 or more and 1 or more. Basically, that's going to modify the previous token, which is our word character. And one very useful is the plus sign. You can see plus sign matches the previous token between 1 and unlimited times. Now we have matches for all of these because we are matching the any word character 1 and unlimited times. So the 1 is very important because let's say our word is only pig, it's not going to be matched because this has to match this match expression. You have to match it at least one time after the pig, because of this is a matches previous token between 1 and unlimited times. So there is a one that with the 0 and unlimited times, which is a asterisk. So the asterisk is going to match previous token 0 and unlimited times. So you see this pig is also now captured. but I'm going to actually leave it at plus. We are excluding the neck group. So how can we exclude the specific naming? What we do is look up use something like a negative look ahead. So after the pig, let me copy this and delete. After the pig, we can put this inside parentheses, question mark, exclamation mark, and then we have to say what we want to. Our negative look ahead is going to be neck, and close it. And then we again want to I'm going to paste my any word character and plus. So you can see it has matched all the groups except for the neck, because this negative look ahead is basically, because this is the positive for these three groups, it is negative look ahead because the next characters are not neck. These are going to be matched, but this is not going to be matched. And what's great about this is that we have always this explanation window. Basically goes through the entire regular expression and explains what we are actually matching and what every token does. Inside regular expressions, we also can declare groups for the parts of our expression, and it's actually pretty simple. We have to basically enclose a part that we match our regular expression inside a question mark. So I think it's actually P question mark, and then the smaller than and larger than signs, and basically we have to name our group big part, like that. Oh, I guess I messed up. I think it's question mark and P, right? So the grouping is a question mark P, and then smaller, larger than, and then the group name inside here. You can see now it's green. This part that we are matching inside parentheses is now green. That means that this face, eyes, and throat is its own group, and we can easily get this information inside from the Python code, inside Python code. And to finish this crash course into regular expressions, I went ahead and copied the regular expression that we're going to use inside our Python module. And I went ahead and copied the names of the files that I expect to match with this regular expression. So I just went ahead and copied a couple of texture names with its extension and without it. And let me go through this regular expression. You can see we're getting three groups: the common name, which is going to be our texture set, our type, which is our base, normal, and all of that, and then the extension. And you can see the extension is actually optional. So you can see that this regular expression is actually matching the with and without the regular with and without the extension. So let me go through this regular expression. So first of all, we assert the position at the start of the line. So this is just to ensure that anything that we are matching, it starts with the word character in front of it at the start of the string. So let's say we try to match this string and it has a white space. Since we are starting our regular expression, finding our regular expression at the, so this is going to make sure that we are starting at the start of the string, and since the white space is not a word character, it's not going to be matched. So if we would actually delete this one, you can see it's actually going to match this also, because it's going to basically try to find this regular expression would try to find this string in entirety of the string, So to make sure that we are actually searching for the only at the start of it, make sure that we add a caret. And then we are matching any word character up until the underscore. So it's basically going to match everything up until the last underscore, which is like this. We can match many underscores, but because of the plus sign is actually greedy, it's going to try to match any word character unlimited times up until we say, okay, so now the next character after the any word character as many times as we want has to be the underscore. So the underscore is going to be kind of a thing that's going to stop the greedy quantifier. After that, we want to create our type group, which is again just the word character as many times as possible. And then we are waiting for the dot that's going to signify that the extension, name of the extension. And inside inside the regular expression, dot is actually a token. Dot is actually any single character. So basically, it's very it basically divides this character that you can use, basically match any character. And since we don't want to use any character, we want to match a literal dot character, we have to use the backslash on the dot character. So we're waiting for the dot, and then we're matching any character you can see, but the next character that after the literal dot character is actually we're using the dot token, because dot token is going to match any character. So this is done because we are not using the any word character, because sometimes there are extensions with the two dots in front of it, something like a bgl.sc. Since the dot is not a word character, it would not be matched. So I'm using the dot character to make sure that I am actually matching the any character that goes after the first dot character. So for the textures, this shouldn't really be required, because I can think of any texture extension that has a multiple dot characters, but to make sure for the matching, I'm going to use the match to match any character. And then the matches previous token between 1 to unlimited times. And then I want to make sure that this is the end of the string, which is a $sign. Right, so this basically makes sure that whatever the string we are providing to our regular expression, it has to match entirety of the string. That means it cannot partially match a string that we are providing to match. So it has to basically assert the end of the line. And since we are in Python, we are only giving a single line strings to match. This is not a problem to have like a multi-line strings to match or anything like that. So make sure that you also use the end of the line. And that's pretty much it for the regular expression that we're going to use. Oh, and also for the, you can see that this is a this expression also matches the both expressions. So you can see with and without the extension. This is because of the question mark, which makes the previous token optional. Matches the previous token between 0 and 1 times, as many times possible. Basically, if we have not added this question mark, we are not matching this because we have no extension. But with the question mark, we actually have it, and this is done because of this regular expression will be used in multiple contexts. Inside Python code, we're going to match against the file name with the extension, and inside Python, inside top network, we're going to use it to match against the file name without the extension. So this is a good thing to add, to not have multiple regular expressions to use. And now let's create two helper functions that I'm going to use. So these two functions are going to hold the Python code that is going to be repeated multiple times across this Python module and also inside top network. So it makes sense for us to go ahead and extract this logic into its own functions and then just call this function to get the information that we need. So first of all, I want to go ahead and get the extension array. So we're basically going to split the file extension string using the white space, prefix it with the prefix each split with the dot, and return it as a list. So this is done because of the way that we are actually matching our extension. Remember that we are actually matching our extension with the dot in front of it. So to check if this extension group that we're going to check for is inside our file, is inside the valid extensions to match, we want to modify this file extension string and return an array. And it's actually very simple code. At the end of it, it should look something like this. So we get our node reference. So node reference is going to come from the parameter that's going to be, so basically from the parameter, from the HDA node. And this node reference, you want to get the parameter of the file extension parameter file extension, and we want to evaluate it as a string. And if this parameter is not empty, you want to go ahead and split it. You can see I'm actually using the list comprehension. So string from the extension is split using whitespace and prefix with dots, since this is a format used in regular array match variable inside here, capture group extension and the top extension attribute. So in top network, when we are searching any directories for files, it's going to basically automatically create the attribute that is that file's extension. And by default in top network, it's actually going to be prefixed with a dot in front of it. So I chose to also add my group that I'm going to match inside here also with a dot. And then we just have to make sure that we're using the same format when we want to check for the file extensions. So we have to go ahead and add dot also for these string for these extensions. And if you're not familiar with list comprehensions, this single line without list comprehension would look in more classical way, would look something like this multi-line code, which is nothing, which obviously is nothing wrong with this code, but it's a lot less readable. So imagine if we would not use list comprehension, we would have to first of all split our string parameter with the white space. That would create a new array. Then we will have to create a new array that's going to hold the new array with the each split that adds a dot in front of it. And we have to then go ahead and loop through the split array and add the dot, basically join the new string and append it to our split list array. And then we would return this split list from the function. You can see this whole code, there's lots of redundancy in it. With list comprehension, we are not creating any variables since we are using all of them only one time and straight away returning it. This is a much cleaner way to do basically exactly the same thing. And also I want to go ahead and return an empty array if this extension, basically if this parameter is empty. So if this returns an empty array, that means that we are matching we are not filtering our regular expression, our texture sets by any extension. The second helper function is actually going to return the file names that we find inside directories that we are searching for our texture sets. So let me go ahead and start copying this code. So we're going to be so instead of the return keyword, we're actually going to use a yield. Yielding is basically like we can basically use a yield as a alternative to the return keyword inside functions. And to show how it actually works, let me show. I went ahead and found this article. If you just search inside Google for the yield keyword inside Python, you'll see something like this. The yield keyword is used to return a list of values from a function. Unlike return keyword, which stops further execution of the function, the yield keyword continues to the end of the function. When you call the function with yield keywords, the return value will be a list of values, one for each yield. So, and in this example, you can see that you can basically create a function where we are yielding different values. You can see we're yielding a string, a number, and a string. And if you put this function call inside a loop, you can see we are actually yielding these values to the console with a print. So this is a really nice way for us to get the file names on demand from the directories that we are searching for. instead of creating one huge list and then looping through it in a for loop. So this is why I'm using the yield function. So let me show how it's actually going to work. So first of all, we want to get our mode, which is going to be node reference and parameter discovery mode. So let me copy this code and show how it's actually going to work. So we are getting our directory. So we are one of the second parameter is going to be the search directory. So first of all, we get our mode from the parameter. Then we get our search directory, and we're using the OS module to search that directory's contents. So it's going to return an array of all the files in that directory, and then we check for the mode. If the mode is batch, we are checking, and remember in the batch mode, we are looking for any subdirectories of our main directory. So we check if the entry is a directory, and if it is a directory, we want to search that directory for the texture set. So this is where we're doing for a subdirectory entry in the scan directory, and this time we are scanning our directory entry. And then if we are checking if that subdirectory entry is a file, that means we can return the directory name, which is going to be our directory entry name. So this is a parameter, this is a property for these objects. And then we want to return also subdirectory entry, and that's going to be the name of it. So the name is going to be our directory entry is going to be the name of the directory, which is going to be in this example the fallen leaves directory name, and the file name, which is going to be this one, subdirectory entry, is going to be a file name with its extension string. And for the single mode, it's going to be a lot simpler. In the single mode, we just want to check if our search directory is a file, basically any file inside search directory, and we want to yield the search directory as instead of the search directory name, we're going to return the search directory path, and then we want to return the directory entry. Its name is going to basically be the same as this property value. Let's move to the main function. In this main function, I'm going to actually return the list object that is required for the Houdini menus to generate entries for the drop-down menu items. So I call this create texture type menu. Processing of regex expression to create drop-down texture type menu for UI. So first we want to create our we're going to provide our Quark dictionary that's going to come from the parameter, and this direction is going to contain our reference to our HDA node. Then we want to get our search directory, which is going to be this parameter. Get our search directory. Then we want to declare a couple of more values. Next, I want to declare the valid extensions. So now I call my helper function going to get valid extension array. Valid extensions, just call this, and then I want to create an empty list that is going to be returned from this function that's actually going to power the drop-down menus inside Python, inside the Houdini. List of menu items for parameters. So next up, I want to go ahead and check if the folder exists. So OS path exists, our search directory. And then for every key and then we want to go ahead and create our default dictionary. And the default dictionary requires us to provide the type of data that every key is going to hold. And since I know that I'm going to hold for every unique texture set, it's going to hold the list. So I have to give a list type keyword list. So every key represents texture set and hold the list of all the texture types found in that texture set. So you can imagine that our unique key is going to basically hold the last part of the every texture name, like base color, bump, and cavity is going to hold the list of all of those items for every texture set. First, now let's go ahead and populate this texture set values. So for the directory file, and now we're using our yield function. So inside yield function, we provide the reference to our HDA node inside here in our search directory here. And now we want to use our regex expression. We're going to use re.match, and inside this function we have to give it our regex expression, which is defined inside here, and the file. And this file is going to be basically the file name that is found inside every one of these, in this search directory. And this is going to basically be the names of all of these inside here. And if we get our match, we want to go ahead and get our groups from this match. So this returns the match object, regex match object, which we can now use to extract data from it. And since in our regular expression we have set up our groups, we can go ahead, check if this match is successful, and extract the groups that we set in our regular expression: common name, type, and extension. So you can see we got our common name, type, and extension groups. Then we want to go ahead and create the unique key for every texture set. So the key is going to be create unique key for each texture set. We use combination of directory plus the name of the actually it has to be the plus the common name for the key to handle edge cases when the common name for the same texture set is in different directories. So this is going to handle the cases when, let's say, our common name is the same for different texture sets in different subdirectories. So there could be this edge case, and that would mean that even if it is the case, it would still be grouped in two different texture sets, since we are also adding to our unique key the directory where it is located. So this is our key. Then I want to go ahead and check for the extensions. So since we want to only add to this our default dictionary the extensions that are inside here, we want to check for the extensions. Only add to the texture set if extension string is found inside the valid extensions, or the valid extensions array is empty. So if we leave this parameter file extensions empty, the extension array is going to return an empty array, and that means that all the extensions are valid. So get all texture types that are already been written. So you can see, even though we have not explicitly created a key, every new key for the for our texture set, for our texture sets, using default dictionary, whatever the key we are asking for, it has already created default value from it. It's basically an empty list. That means that we can get a variable for the types just by texture sets and then providing our unique key. So in the first loop, as you could imagine, it's going to be empty. And if it's empty, that means that it's our type. Type group is not yet added to the list of all the types for that texture set. That means you want to go ahead and append it to it. It's going to loop through and append to each one of these texture sets all the types that it has found for it. At this point, we could start to go ahead and return all the types that it has found, HDA has found, and create our drop-down menu. But remember that we have this option to show only common types between all the texture sets. That means we have to go ahead and filter this data if this parameter is enabled. So let me go ahead and copy this file, this code. So indentation for, so after the for loop, we have to do something like this. So we have written to our texture set default dictionary. At this point, we can populate our parm menu or filter data to make sure that only data that is common to all texture sets will be shown from drop-down menu. So we get our parameter show only common types, and if this is checked, we want to do couple of things. So first, we want to go ahead and loop through all the values that we have written to our default dictionary. So I call this a texture set and values. So this right now, this value is basically a list object of all the types for each texture set. And now, since we want to match against every other texture set, we want to go ahead and loop it through it again. For each texture set, we loop through each texture set again, since each texture set must be checked against all other texture sets. So now that we are looping through it again, we want to go ahead and copy the texture set and loop through it. The loop through copy because we might have to delete items from our texture set from the main texture set that we are checking. We do not want to loop through it since we might have to delete items in it. So what we do is actually go ahead and create a copy of it. So remember, this texture set object is tied to this texture set default dictionary. So anything that we delete inside this loop will be reflected in our default dictionary. So that's why we do not want to loop through it and delete it while we are looping through it. So we basically create a copy for it. And what we are doing is pretty straightforward. While we are looping through the old texture type that we have inside our texture set, we want to check if this type is found inside the texture set array. And basically, if this type is found inside each of the texture set that we are looping through while we are checking each one of the texture sets on top of this loop. And if it is not, we want to go ahead and remove that texture type from our texture set. And that's pretty much it. Once we have cleaned our array, we want to fill this param menu and return it. And it looks something like this. So this is still handling the if only show common types. We check if this texture set is a valid object, and basically want to go ahead and get all texture types. And since we have cleaned up our directory to make sure that all the values that each texture set holds are the same, we can go ahead and get the first key of that default of those texture sets and return it. So you can see that get all the texture types with show only common types enabled. Only all key values are the same, so we select the first key. So you can see it's a little ugly line, but I found it the easiest way to do it. We're basically getting our texture set, we are getting all the keys, and we are converting it to the tuple because the keys object doesn't support value indexing. And since I want to get the first key, I have to convert it to something that supports indexing. So I convert it to tuple and get the first index of the value, and then basically get its key, and I get the default dictionary and basically get that key like that. And then since our menu item requires a value and the string value for it, we have to append each item from our types list twice. So for every menu items, we need its value and display name. We use the same string for both. So param menu append type 2 times. And then this basically has handled the showing of only common types. And to handle the unchecked parameter, it's a lot easier. What we can do is else statement. If the common type is not enabled, we just go ahead and through every texture set, we get the values, and for type texture set, we go ahead and if the type is not already added to the menu, we go ahead and append it, and that's it. And make sure that at the end of it, we always return param menu. Let's go to the type properties of our HDA node. Let's check if the script is successfully saved in Python module. You can see all the code is inside here, so that's good. Let's go ahead and call this main function for our menu items. Go to the parameters, and we want to find our file parameter, and we want to go ahead and go to the menu and use the menu script. In this menu script, we can use Python code. So let me paste inside here. I call this tags. So I could probably simply call like let's call this a better menu. So the menu is getting our Houdini, getting our Python module, which has a shortcut function, which is who.phm, and then we want to go ahead and call our create texture type menu, and provide our Quark dictionary that comes, which is available when we call any code from this window in HDA. So once we have called our main function, we want to go ahead and create and return it like that. Return our menu item array, not array but list. And we want to go ahead and basically copy it for all the file parameters. File, so that's going to be file R, G, B, and also make sure you press apply so that it saves for each one of these windows, and on also file alpha. And we should probably, and this should already work. So let's try it out. Let me close this. Let me press plus sign, and you can see the menu items are working very nicely. So I'm pointing to the materials folder, which is inside here. And since we have our batch mode, this works correctly. Let me put it in single mode. This should be empty now. That's correct, because we have no files inside here. Let's go back to the batch mode. Let's try out this show only common types. So let me go ahead and delete something like a base color from one of these texture sets. And now, so the base color is still here, but let me only show common types. So you can see the base color is gone. Let me disable it, and base color is back on. The menu is successfully created, and see you in the next video.